This is the first revision of chapter 4 of class 10 standard ICSE Xth 2025-26. First topic is we need to learn about what is the moment. So moment of a force. Moment of a force. So when his force is applied on already we know that rigid bodies and non-rigid bodies. Rigid bodies means they can when a force applied it moves, and non-rigid bodies shape also changes. But in the rigid bodies there are two types: free to move and one more is pivoted. On free to move, where force is applied, it moves in a straight line. That is called translation motion. And when a force is applied and pivoted, it rotates. Right? That is we are studying about how it rotates. The factors of this one we have learned here, and applications, something like that. So when pivoted, right? I told pivoted. This is on pivoted object. I am applying force here. This is a pivoted point. Something O at D. I am applying the force. So how to due to this force, it produces an rotation here. We need to calculate how much force moment of force is created here using the formula F is equal torque. That is called torque. Moment of force, that is called effect of turning effect of the force. Turning effect of the force. This is related by torque. This is F into perpendicular distance from O to D. OD. This is called point of rotation. This is called point of application of force. Application we are writing here. This one simply we can write F into T, torque is equals to F into R also. This is one concept. Next topic. So types of bodies over, types of motions over, translation motions, rotation motions, and turning effect of the force, that is the moment of force we just learned, that is the torque. This is the called axis of rotation and pivot, which is passing through the pivoted point, and axis of rotation over, and line of action of force, this is the line where which is passing through the point where the force is applied, and this is called point of rotation also, axis of rotation. Okay, next topic. Next topic is factors affecting this torque. So one is the magnitude of the force. So force increases, our torque also increases, and distance. If distance increases, torque also increases. For example, there is a spanner. Okay, we are opening nut. From the nearest to that nut means we have to apply more force. Going away from that nut, at the end, go to the end, we have to apply least force. Least force always applied at the edge of the door, edge of the spanner, something like that. Next one, getting maximum torque to turn the body means we need to go to the edges. Means we need to increase this distance, perpendicular distance between the point of rotation and point of force application. Okay, units of MIF. This is the Newton meter. Okay, Newton meter, and CGS is dying centimeter. Sometimes we are using kg of meters also. If it is in kg of weight is in kg of, that should be distance should be in meters, and if it is a g of gravitational force, then we need to use centimeters. Okay, that's it. Then the weights are given. Weights also acts as a force. Weight of a body also acts as a force. So after forces, we have to study about the weights only. That we will do later. Then next topic is topic 10. Clockwise movements, anti-clockwise movements. See, there is a bar is there. Applying force is this side, and force applying this side here. Opposite directions. Then and even pivoted point is this one. About pivoted points only the force are rotating the object. So it applies here like this in this way. This is called anti-clockwise. Sorry, this is the clockwise direction, and it also clockwise direction. Do one thing. Otherwise, okay. Put one more force here. It will turn like this. It is called anti-clockwise direction. So anti-clockwise direction. This moment is called anti-clockwise moments of force. This is called clockwise moments anti-clockwise moments of direction. It is considered as a negative and it is considered as a positive. Okay, next, directional force over. Sometimes how to change the direction means the point where you are applying the force. If applying force, it will go like this. If applying here, it will come like this. Or change the direction of the force also. If you are applying in this direction, it turns like this. If you are applying upward direction, it turns like this, anti-clockwise, like this. Changing the point of application of force or change the direction of the force, we can change the rotate the things. Next, couple. Couple is means two things. The point of force found by external force and force of reaction. In case of non-rotational something wall is there, here we are applying, sorry, door is there, applying force to open, the hinges also giving force of reaction at the same time. Like the two forces are acting, like these two forces are called couples. Okay, but in case of completely pivoted in the middle, something like rotation things, the two forces should act now anti-parallel lines, means at different places they have to act equal forces. This is 5 newtons, this is 5 newtons, the distance is 10 meters, means we can find the resultant moment by using formula any one force into distance between them. 5 equals to 10, 15 newtons. This is called couple. Okay, either a force into perpendicular distance between them. For example, we can create there is an what is that steering. The distance between them is 1 meter, means we are applying force here 8 meters. Here also we are applying 8 meters in this direction. This is in this direction, right? So what is the moment of resultant moment created here? 2 meters, 1 meter only. 8 into 1 equals to 8 Newton meters. Like that we can do. Okay, next. Next topic is couple work equilibrium bodies. Equilibrium means there is a seesaw. We need to make it as horizontal, so this should be balanced. Means whatever force here applying, or the force that applying, that should be acting at the pivot point should be 0. Okay, this is called equilibrium. The resultant all force is 0. The algebraic sum of moments of the forces about the fixed is 0. Okay, when the fixed point is 0, change the rotation and take the. Okay, we don't change the rotation or state of the body. Okay, a single force makes rotation to produce a sustain to state of the not state of rest or state of the motion. A body perceiving its state in the presence of two or more forces is said to be in equilibrium. So many forces are applying here. There is a book on the table. I am applying force here, applying force like this. But all the result force is 0, means that is in equilibrium only. Circular motion also is this. The static equilibrium. In a body remains in a state of rest under the influence of several forces. The body is in static equilibrium. It is at a rest. Body force are applying so many, so it is still in the rest, means it is in equilibrium. A beam balance also. A beam balance is there. Doing acting, weighing here. It is keeping horizontal, means over. Balance in horizontal position. The CW clockwise motion due to the object and its right pan. Balance the anti-clockwise moments of forces due to the weights on its left pan. B. Has no rotational motion. State is called equilibrium. Okay, when a body remains in the same states of motion under the influence of several forces, the body is said to be dynamic equilibrium. When a body remains in the same states of motion, maybe translational motion, maybe. So, for example, it is a straight line, car is going 7 over time without changing anything. It is called translational equilibrium. Okay, dynamic equilibrium. Running fan also, this is the dynamic equilibrium. So then what is the condition? The resultant of the forces acting on the body should be 0 in the case of things like this, keep in the rest. And when you are moving rotation, means the sum of moments of forces acting at that point, about the point of rotation, of moments of all the acts the body about the points of rotation is 0. Okay, that's it. That's how we will get a new principle according to this one. Sum is equal means we can say anti-clockwise moments of force equals to clockwise moments of force. If anti-clockwise positive, you have to take this numerical center of gravity. So if any material having so many particles and each particle is having a weight, they're going also downwards. So instead of taking all the force, we are taking a small point and noted as this one is a capital W. Okay, it holds the complete weight of that body, where that body we can hold like this and balance it. Okay, that's why this is a 0 of forces, moments of forces of all these things here becomes 0. Moments of forces, moment of forces. Okay. For irregular lamina, we can use a plumb line. Here, middle point is there, G and balance point. That is the G is the balance point. We can balance from there. After that, we have uniform circular motion. Speed is constant. Direction of motion of the particle is different. For example, it is going here, same speed is there, but what happens? Direction is changes. So velocity is variable. Circular motion is an isolated motion, even though speed of particle is uniform. Linear circular motion. In linear speed and velocity both are constant, and the isolation is unisolated, and this is isolated. Centripetal force. A force is needed to change the direction of a motion of particle. Particle is going like this. You have to apply the force again to turn like this, turn like this. That is called centripetal force. Okay, it is always acts towards the center of the circular path. A force assumed, what is centripetal force? Centripetal is assumed by an observing with the body, assumed to be acting on the body in a direction away from the center of the circular path. It is like this, it is going some opposite direction. But this is not a reaction of the centripetal force, because they are acting in the same body. The action reaction should be acting in different bodies. It is a fictitious force opposite to the CPF.